Hey everyone, and welcome back. This is a step-by-step example for definite integrals and substitutions. So this one actually came to me by request. Just as a reminder, I do take requests. And so here's the problem. So this one actually was simplified in kind of a strange way. So I'm going to walk through every single step for this. So to begin, so the thing that you're looking for here is you've got to use substitution for this. Just looking at this, we don't have a nice integration formula to deal with this. So right away, you've probably got to use substitution. And so then in thinking about this, you'll notice that if I set my u, let's see, I'll use this color, my u equal to the natural log of x, well, what would my du be? My du would be, I'd take the derivative of the natural log of x, so that's 1 over x, and then dx. So that's the derivative. Okay, so this tells me right away that I'm going the right direction because here's my natural log of x, so I would substitute this part. And then the 1 over x, that will take care of this 1 over x right here and the dx, so we've got the perfect substitution. Now, this is also a definite integral. My preferred method for approaching this is to go ahead and change the limits of integration. So let's go ahead and do that. So the idea behind this is, so if x equals 2, so I'm starting with the lower limit of integration. So if I start there, then what does u equal? Well, to figure that out, so for u, I go back to what I actually set my u equal to right here. And so I'm just going to plug in then x equals 2. So if I plug in x equals 2, this becomes the natural log of 2. So that means then my 2 is going to be replaced by the natural log of 2. And now if I go to the upper limit of integration 4, so I can use this same logic. If x equals 4, then what will u equal? U will equal the natural log of 4. Again, notice I'm just plugging 4 right into what I set my u up into. All right, so now I'm going to take all of this and rewrite the problem. So for my limits of integration, my 4 will turn into the natural log of 4. 2 will turn into the natural log of 2. And now, be careful when you're doing this next part. So for my 1 over x dx, that's now all going to be just replaced with my du. So I really just have to think about this natural log of x. So if I replace that in here, I'm still left with this power to the 6. So this will turn into 1 over u to the 6 du. And for simplification, I like to think of that as just u to the negative 6 du. Okay, so now we're in business. We can go ahead and integrate. So in integrating this guy here, this is going to equal negative 1 over 5 u to the negative 5. So remember, you are adding 1 in this case to the exponent, and then you've also got to multiply by this constant here. And then you can also remember, oh, if I were to actually take the derivative of this, this will get me back to u to the negative 6. Now this is a definite integral. So I didn't need the plus c here. Instead, what I need is I just need to make sure that I kind of have this little bracket here to show that I have to still evaluate this. Okay, so now let me clear some space. And now we can go ahead and evaluate this. So I'm just going to plug in my limits of integration. So this becomes negative 1/5 times the natural log of 4 to the negative 5th minus, and let's see, I'll use this square bracket here, negative 1/5 times the natural log of 2 to the negative 5th. Okay, so the reason that this question was actually asked to me was this was simplified in kind of a unique way. So this is going to be one of those problems where if you have to simplify it all the way, you can't just put it in as a decimal. It's going to require a little bit of heavy lifting with algebra. So first things first, I want to factor out this negative 1/5 just to make this problem easier to look at. So I'm going to rewrite this as negative 1/5. And then I'll also rewrite these natural logs like this. So I've got the natural log of 4 to the 5th minus the 1 over the natural log of 2, all of that to the 5th. So I got rid of the negative exponents. Okay, so now here's where the creativity is going to start to come in. So let me make some space. Okay, so if I tried to simplify these fractions just as is, and without making any manipulations. Just notice like it wouldn't be a very illuminating result because it looks like at the moment maybe these have nothing in common. But think about 4 for a moment. This is where the cleverness comes in. So 4 I could rewrite actually as a power of 2, and there is a giant hint in this problem that I probably want to do that, in that this is the natural log of 2. So this is the natural log of 2, and I could rewrite 4 as a power of 2. So let's see what that gets us. So this is going to be -1/5, and then I've got 1 over the natural log of 2 squared, all of that to the 5th, and then you've still got this other guy over here. Okay, so now thinking about what we know about natural logs, or just properties of logarithms, I can totally take this 2, right, and just bring it out in front. So if I write that out, that's going to be -1/5, and then 1 over 2 times the natural log of 2, all of that to the 5th power, minus 1 over the natural log of 2 to the 5th. And so now this is actually where things are going to get interesting. So I can break this up again, so I can kind of like use what I know about exponents and take 2 to the 5th here. So maybe I'll write out one more line before I kind of move on. So let's see, I've got 1 over, so this is going to be now 2 to the 5th, and then the natural log of 2 still to the 5th, right? So I just broke up this 5th power to each part inside the parentheses. And let's see, I'll make this 5 just slightly easier to look at. And then this is still the natural log of 2. Okay, so now let me clear some space. And now let's just kind of keep chugging along with simplifying. So I can rewrite this now. I've still got this -1/5 here. So what is 2 to the 5th? So 2 to the 5th is 32. I had to get out my fingers and toes for that one. Natural log of 2 to the 5th. Okay, so now check out what we have. As far as this problem goes now, like I'm much closer to this is not to the 5th, this is 2. I'm much closer to having a common denominator now, right? Like these look very similar. So I would just have to make one manipulation to this. What would I have to multiply this by? I would have to multiply the top and bottom here by 32, and then I have the same denominator for both of these. So I'm just going to note that here. I'm going to multiply this by 32. I'll multiply this by 32. So now let's see what we get. So now I've got -1/5, 1 over 32 times the natural log of 2 to the 5th, minus 32 over 32 times the natural log of 2 to the 5th. And now from here I can simplify this and turn this into just one singular fraction right here. So I'll make some space again. And so let's just keep pressing forward here. So this fraction now is -31 over 32 times the natural log of 2 to the 5th. And so now I can multiply this fraction with this one. So this will become just 32 over 160 times the natural log of 2 to the 5th. And if you're just trying to get a decimal, then this problem would have been a lot simpler. But if you're being forced to simplify, which I know that the homework system that my class uses does force you to just simplify, it is quite a bit of work. So and a little bit of creativity. Okay, so if that was helpful to you, please consider liking this video. If you subscribe, that's super, super helpful to me, or leave me a comment. That's always helpful. If there's ever a request that you want, if you're one of my students, you can email me. If you're not one of my students, you can just comment. And I will see you guys next time. Thanks for sending in that request.